Let R be the region enclosed by y equals x over 2 plus 2, the line y equals 5, and the x-axis. So it's got kind of like this like wedge. Let R be a solid whose cross sections are perpendicular to the y-axis are squares. Okay, so because it's starting big between 2 and 5, that's a bigger square, and then it's getting down to a small. So it's kind of like, it would be kind of like this. Like, I'll draw the bottom edge, but there's a big square, and then there's a smaller square, and then there's a smaller than that square, and then a smaller than that square, until it's actually nothing. And so it kind of has this like fall down to a point. Not quite like a pyramid, but certainly thinking pyramid. Okay, so it's still, even though it has, I said pyramid, and I'm kind of thinking behind it, I'm thinking volume is base times height. We're still referring back to that formula. So volume is base times height. And I know that this is going to be the integral. So B is the integral from 0 to 6 of 5, the top line, so everything below the 5, minus the function on the line x plus 2 over 2, and then the height. The height depends on, cross sections perpendicular. So this cross section is 3 in length because it's going from 2 to 5. So how do I reference that? It would be the cross section, I don't know if I spelled that right, but whatever, cross section area would be 5 minus 0, which is, no, 5 minus 2. Maybe it's not 5. Maybe it's the maximum is 3. So 3 minus 0 at the beginning. Well, I'm really struggling. Okay, I'll make it be an ordered pair. So at x equals 0, the cross-sectional like edge is 3, which translates to a height right there of 3. And then all the way at x equals 6, because it comes to a point, the cross-sectional area is 0. So I need to take 0, 3, and 6, 0 and write a linear equation. 0 minus 3 over 6 minus 0, negative 3 over 6, negative 1/2. So the function for height, this is the function, I should use h. The function for height is negative 1/2 x plus 3. Yeah, put a 0, put a 0. The height at 0 is 3. And then the height, put a 6, so negative 1/2 times 6 is negative 3. At 6, this has no height because it's all come together. There's no like large like square right there at the corner. So yeah, this is my function for height. So I have from 0 to 6 of 5 minus, and then I just got to take this function and throw that up in there. And oh, lovely, it would be that way. Wait. Perpendicular to the y-axis. Well, that's a little irritating. Okay. So same idea. But sideways. Okay, so I'm going to draw it over here. 4, 5, 6. Y-axis, x-axis. I still maintain Oh, it looks like this. Oh, so this is the small square, bigger square, bigger than that square, finally to the maximum square. So it still has this like wedge shape idea, but the point where it all comes together perpendicular to the y-axis is here at 0, 2. And biggest here at 6, 5. So there, right? That makes me think though that I can then talk about like this face right here. So at y equals 5, the cross section is 5. And here, where y equals 2, the cross section is 0. So when I look at it this way, it's the area under the curve. It's the area under is weird. It's the area with respect to the y-axis. There's only one function that does that. So I'm still building this volume equals base times height formula. Oh good, I haven't lost the feed. This information will tell me the height when I make it into a function for y, because this is y in cross-sectional like side. But in order to integrate the base face, I got to take the y equals x over 2 plus 2. I got to get this to equal x. I got to flip or invert the function. Cross section's perpendicular to the y-axis. So let's do minus 2 equals x over 2. 2y minus 4 equals x. This is what I have to integrate from 2 to 5. Okay, so the integral from 2 to 5 of 2y minus 4. And now I got to take this function. So 5 minus 0, 5 minus 0 over 5 minus 2, which is 5 over 3. So the height function is, don't show it, 5/3 y minus 2 plus 0. 5/3 y minus 10/3. They're still telling me that I'm wrong. Could it be? Could it really be that one? I bet you it is, and I bet you I know why. Yeah, okay. Okay. Duh. So A is the right answer here, and for cross all that out. Okay. Squared dy. So the reason for it to be A, that first answer for me, is it's still going from 2 to 5. But right here at 0, 2, I'm off my rocker. No, I'm good. Okay, I was gonna say that the distance between, no, okay, yeah, okay. So when I took this original function, y equals x over 2 plus 2, when I took this function and I solved it for x, now when I plug in a 2, x of 2 equals 2 times 2 minus 4, I get 0. Show it. Work. There we go. X of 5 equals 2 times 5 minus 4. Oh, I did do that wrong. This is a 6 and this is a 6. Oh, I'm so glad I didn't get it too messed up. Okay, I did all this right. I just wrote a 5 and a 5. And if you caught that earlier, kudos to you. Let's see. how ridiculous does this thing called commentary? I'll have to look it up. But they do this thing where they recognize, like, if you catch a mistake, the first person to catch the mistake wins. They give up something stupid. So anyway, pretty cool stuff there. Mark Rober and them dropped a car off of like a 500-foot tall tower onto a trampoline. The car bounced. It was nifty. Good way to spend like Pi Day. Okay, so I wrote the wrong point up here. Thank you for catching up. I wrote the wrong point. I wrote 5, 5. I saw the 5 and got distracted. I wrote a 6. The height of the square created there is also 6. So that's why it's 6 and 6. Do this math properly, and you'll wind up with that same equation, 2y minus 4. And yeah, that's some behind the scenes. I'm going to pause it. And thanks for watching this behind the scenes version of me answering another math question and getting it right. Comment, like, subscribe, ring the bell. See ya!